10.5 is on the binomial theorem. We are going to also talk about some of the components that are involved with the binomial theorem. Factorial is like an explanation point, but in math that means you take the number that's in front and you multiply by one less, and then one less than that, one less than that, all the way until you get down to 1. So, for example, 5 factorial is 5 times 4 times 3 times 2 times 1. When you multiply those together, the value would be 120 for 5 factorial. Sometimes you get really large values and your calculator can't handle it because as you keep multiplying, your calculator only has a certain number of digits of space. And so if you're doing arithmetic with very high factorial values, then you might want to make use of some of the reducing properties. For example, if you're doing fractions, you could think of this as 9 times 8 times 7 all the way down to 1. 3 factorial is 3 times 2 times 1. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. But instead of having your calculator figure out the whole value of this, you could recognize that from 6 all the way to 1 is going to cancel out with this 6 all the way to 1 factors. And you can even reduce further. 3 goes into 9 3 times, 2 goes into 8 4 times, and so in the numerator you have 3 times 4 times 7 times a bunch of 1s, 84, and on the bottom you have, for the denominator, a bunch of 1s multiplied together. So 84 divided by 1 is 84. To simplify writing it, you can also recognize, oh, there's going to be 6 all the way to 1, so why don't I just go from 9, 8, 7, and then represent 6 all the way to 1 as 6 factorial. Then these are really the same values, 6 factorial over 6 factorial, and so you can save yourself writing 6 all the way down to 1, 6 all the way down to 1, and canceling all those out. You can find the value of factorials in your calculator, and you can also add them and multiply them. Multiplying is what we did here. We divided this way. You can also add them or multiply, like for example, 2 times 5 factorial. If you do 2 and then 5 factorial in parentheses, it would be twice this. So to find that in your calculator, you are going to look for the probability menu. And I've pulled up a couple different calculators. So I'll start with one of the very common scientific calculators that my students typically have. The probability button is right here. And when you click on it, you will have a menu that will have the factorial symbol. Other calculators like this one, I've seen several of my students have this type as well. There is a factorial button as well on here, and it is located right above the 3. You can see the x factorial. So to use it, you'd say like 6, push the 6, and then push second and the 3 to get the factorial for 6. With the TI-89s, there's the second and the 5 gets you a math, and in math you can find some of the probability menu options. And with the 84, again, there is a math option right here, and you scroll over using the right arrow to the probability, and there's the factorial. While we're on this calculator, right above it, you'll see NCR. That's for combinations, which we will also be using in this lesson. And the combinations on the 89 are also found second math and then going to probability menu. And you'll find that near the factorial. The scientific, you go to probability, and aside from the factorial, there's also another option if you hit to the right once for NCR. And for these ones, the NCR is right here above the 8. So you'd hit your N value first, then you'd hit this button by hitting second 8, and then you'd hit your R value and then enter. So here's kind of a summary of the factorial buttons for different calculators. It is used to find the NCR is used to find the binomial coefficient, which is part of the theorem we're going to be making use of. You can also find that value, the NCR, by the NCR formula that involves the factorial, which I have right here. NCR is a formula that makes use of that factorial notation. The binomial theorem is the sum of a certain number of items that, in this case, it corresponds to your exponent or your binomial expression. So this is where you're trying to expand a binomial two-termed expression raised to some power. So instead of writing x plus y, x plus y, x plus y out, maybe let's say 3, 4, 5, 10 times, you can make use of this formula and you wouldn't have nearly as much of the foiling and the distributive property. It's just much easier when you get to higher values of n. When n is 2 or 3, FOIL and then distribute is probably easier than applying the theorem, but from like 4 on, often this theorem is actually a quicker way of calculating the expansion of the binomial. This is a little bit cumbersome to make sense of, but basically you can see that you have n and r's being used a lot, and the n and the r, the n corresponds to the n, the exponent, but what is the r? And so you're going to see, I think, a little bit better here. If you have some binomial, a plus b to an nth power, your first term is going to be made up of this binomial coefficient. And in probability and statistics, if you take a probability course, you'll learn a lot more about the binomial theorem and its application. Here we're just going to go through the mechanics of finding the values in terms of trying to expand a binomial expression. So NCR, so the number of items you have to choose from, and you're finding the combinations of those made up of this many. So for example, if you are trying to figure out how many combinations of pizza can you make if you have 7 toppings to choose from and you want 3. So it'd be 7 choose 3, or 7 combinations of 3 items. So that will get you your coefficient. The 7 is consistent. You just can either choose 0 toppings, 1 topping, 2 toppings, 3 toppings, 4 toppings, 5 toppings, 6 toppings, or all 7 toppings. And so that's where these different terms come into play. So you'd start with all your options. Your first term actually corresponds to 0 options, 1 option, 2, 3, etc., all the way down to picking all 7 of your options, if n is 7. And then you have your first term to the nth power, whatever your exponent is, and your second term to the 0th power. And you start trading off. You go 1 less, but then 1 more for that exponent, then 1 less, and then 1 more, and then 1 less, and then 1 more, all the way until you get down to 0, and you get all the way up to your n. And so here's the kind of pattern. If you get a note card, this might be a helpful pattern to write down. Once you get comfortable with the process, that's often just enough to get you going. Sometimes people like writing down like 1 or 2 of the terms just to remember the whole process. This is being multiplied by this, which is being multiplied by this. There's a couple patterns you might notice that are useful if you're doing some of the more challenging problems where it's asking you for example, what is the 532nd term of something that's raised to like the 600th power or something. You wouldn't want to do all the terms, but you can maybe do that particular one using this pattern where this is always your exponent. This is going to be 1 less than your requested term. So for example, your second term, you can see a 1 there. Your third term, you can see a 2 there. Fourth term, you can see a 3 there. And then these are always going to match like you can see here, it's the R and the R. And then these two always add up to your N. So I have that kind of summarized here. A couple things that come into play with this lesson as well is that anything to the 0 power is 1, a negative to an odd is negative, a negative to an even power is positive, and don't forget, if you have multiple factors, that your exponent becomes the exponent for each factor if it's the whole thing to the nth power. So just wanting to talk about how do you find that NCR part. So as I mentioned at the beginning of this video, there is the NCR formula as well as your calculator under the probability portion of your calculator, which on a scientific, often it's under probability, or sometimes you see the NCR button itself. In the 84s, it's under the math menu. In the 89s, it's also under the math menu, which is second and then the 5 button. And then you go to the probability from there. Put your N value in first and your R value second. Or in the other one, put it first, then go into the function and then the second, and then enter. So you can see 7, select your option, 3, and then enter. Here you have the input as 7, 3 in parentheses. So there's the calculator directions. You can also find it, interestingly enough, by using Pascal's triangle. Pascal's triangle is where you have ones along the outer edge, and each term is the sum of the 2 above it. Again, the sum of the 2 above it. And so anything to the 0 power is 1. When it's to the first power, you just get your binomial. So a coefficient of 1 in front of each would just get you that binomial. To the second power, you end up with, we've seen that pattern before, a squared plus 2ab plus b squared. And it becomes, when you square something, a trinomial. So there's the coefficients for the 3 terms. I'm not going to be able to explain or give you an example you're familiar with probably from higher powers, because we don't do much with higher powers until now. But the coefficients are 1, 3, 3, and 1, and then it's 1, 4, 6, 4, 1, etc. Please don't mistake it for being like that this is being added or subtracted or multiplied or divided. You actually have to use the probability feature or use the formula right here, or Pascal's triangle. So if you wanted to find out 7C3, you'd have to go out to where it has a 7 here in the second spot. It has 8 terms because you always have one more term. You always have that constant term and the 7th power term for something to the 7th power. And the other option is just to remember you always start with 0 power and then go to the one that would be 7th power. So this is kind of limiting when your exponents get a lot higher, and then your calculator becomes much more useful. So this is 7C0, 7C1, 7C2, 7C3, 7C4, 7C5, 7C6, and 7C7. So here's my A, my first term, here's my B, and here's my N for this example. Again, start with my N, and I do C of 0, then 1, then 2, then 3, then 4, and I stop when these match up. So again, start at 0, end at N. Put your first term and raise it to the exponent all the way down to 0, and then the second term with 0 all the way up to your exponent. Again, in parentheses, it's that whole expression. So it might have just a number, or it might have just a variable, or it might have a combination. So when you find these values, again, you use either Pascal's triangle, which you can see I've done here, or your calculator. This will be 1, then 5, then 10, then 10, then 5, then 1. 1, 5, 10, 10, 5, 1 for each of those. Then for the a to the 5th, 2x to the 5th, it's 2 to the 5th and x to the 5th. So use your caret symbol on your calculator, or if it's easy enough, you can just go 2 times 2 times 2 times 2 times 2 and get 32. And then x to the 5th. Similarly, 2 to the 4th is 16, x to the 4th, etc. Anything to the 0 power is 1. Then here, anything to the 0 power is 1. Negative 3 to the first, a negative to an odd will be negative. But here it's negative 3 times negative 3. So you can see a negative to an even is going to be positive. So you'll end up getting an alternating sign pattern when you have a negative for your base because your exponents are alternating between evens and odds. And again, just make sure you're squaring and cubing and doing the 4th power of each of your factors. Then you're supposed to multiply all these together. So I multiply all my coefficients, all my numerical factors. Then I multiply my numerical factors and put my variable ones as well. Multiply the numerical factors to simplify it to 720, x to the third, y squared, etc. So as an expansion, this would actually be this whole thing. I just do it vertically. Sometimes people do it horizontally. I just find the patterns a lot more obvious to me and easier to track and takes up less room. I mean, it goes really long. If this was all written out vertically, it just would sometimes take more than one line. It's just harder for me. So I like doing it vertically like this. So here's another one. The exponent is 3. So now I have 3's here. Always start at 0. Go to your n. Your a, start at 3. Go to 0. Your b, start at 0. Go to your n, which is 3. Pascal's triangle with 3 would be this line right here, 1, 3, 3, 1. So 1, 3, 3, 1 for my coefficients. X to the third, x squared, x to the first, anything to 0 is 1. Anything to 0 is 1. 5 to the first is 5. 5 squared is 25. 5 to the third is 125. Multiply across. And those are your terms. So if you wrote x plus 5 times x plus 5 times x plus 5, you FOIL the first two together, and then you distributed in combined like terms. This would be your expression. I actually did this same problem in an earlier lesson way back when we were multiplying binomials. I think it just was maybe a y here or an m or something. Find the first 3. So this one is just recognizing that these numbers get very large when you have, higher exponents. And so 60, 0, I would use my calculator, so I'm going to have to do 3 of them, or maybe I do Pascal's triangle just because 6 isn't too bad. In fact, I think I already have 6 here, 1, 6, 15, at least for the first 3. So 1, 6, 15. And then 7x is my A, and negative 5y is my B. And so start at your n and work your way down. Now, future terms would go all the way down to 0, but we only wanted the first 3. Start at 0, work your way up. Some of my students get confused here and they think that they should do like 2, 1, 0, and then 0, 1, 2. These have to add up to your n, and you're always starting with your n and working your way down. It's just that you didn't bother going all the way to your 7th term. This would have 7 terms, one more than the exponent. So again, find the value of 7 to 6, 7 to the 5th, 7 to the 4th, and negative 5 to the 0, negative 5 to the first, negative 5 squared. Because it's negative, again, you're going to be alternating with your signs. A negative to an odd will be negative, but the others will be positive. Multiply and cross, and there are your first 3 terms. Find the 5th term. So you could find the 5th term by finding the 1st, 2nd, 3rd, 4th, and 5th and just stopping there and setting it up that way. But if it's a much bigger one, you might not want to do all the setup and just use that pattern I mentioned earlier, which is also right here, where your n is always there, then c, of course. 0, this is going to be 1 less than your term number. Your a, your b, these match up. These two have to add up to 12, so I had to have an 8 there. And it matches up if you had set it up. But again, if this is asking you for like, a much bigger thing, you might not want to do all the work of the setup. You can even see I didn't write the 3x and the 7 all the way down. I just did a ditto dot. And they get very big very quickly when you have higher exponents. And so this expression, the fifth term would be this long, very long coefficient of x to the 8th. So I hope that that helps. The main thing I want to make sure you are aware of, these things multiply. How to find this is either Pascal's triangle or your calculator, or technically the formula, but I wouldn't recommend that. And then make sure that you are raising each of your factors to that power. All right, good luck.